Alright, this is 6F notes. Today we're going to be simplifying and adding and subtracting radical expressions and rational and radical expressions. So in order to do this, you must have like terms. So the way we have it right now, we can't do anything. We need to simplify first to see if we get like terms and then add our like terms. So that means our radicals and our variables must be the same in order to be able to add them. Okay, so what I suggest you do are these following steps. So write them down as we go through this process. First of all, rewrite as rational exponents first. So what I'm going to do when I look at this, I'm going to see that 32. I'm going to think, okay, what can I break down 32 into? Well, the lowest base is going to be 2 to the 5th power. So I'm going to rewrite 32 as 2 to the 5th power, x to the 6th, y to the 5th, all to the 1/4. Alright, plus, well, my 2 is the lowest base it can go, so I'm going to leave that as 2, x to the 6th, y to the 5th, to the 1/4. Now I'm going to apply my properties. Okay, so apply my properties. So this becomes 2 to the 5/4, x to the 6/4. Don't reduce that fraction because we want to keep that same index. And 5 to the 5/4. Plus 2 to the 1/4, x to the 6/4, y to the 5/4. Alright, don't add these until we've changed them back into radicals. So we're going to simplify these and change them back into radicals. So I see some improper fractions. So that means that we're going to take things out of the radical and some things are going to stay in the radical. So if you need to at this point, you can rewrite these as mixed numbers if that's helping you see this process. So it's 2, 1 to the 1/4, x is 1 to the 2/4, y 1 to the 1/4, plus 2, 1/4, x 1 to the 2/4, and y 1 and 1/4. I'm sorry, 1 and 1/4. Okay, now remember the whole numbers get to come outside the radical. The fractional parts stay inside the radical. So when I simplify this, we're going to have a 2 outside. I got a 4th root, and a 2 is going to stay inside. All right, my x term, an x comes out, and x squared stays in. And finally, my y term, a y comes out, and a y stays in. All right, let's do the same thing with the second term. All right, 2, that's going to stay in the radical, so the 2 stays in. X, and x comes out, x squared stays in. A y comes out, and a y stays in. So in order to be able to add like terms, the radical and exponent part and variable part has to be the same. So since these are the same, we're going to keep that. This is a coefficient of 1. So our final answer is 3xy, the 4th root of 2x squared plus y. It's just like adding terms like 2x plus 1x. We just got a lot more, our variable terms are just a lot more complicated now. So this is our final answer. And your final answer needs to be in simplified form. Okay, let's look at another one. All right, now this one's already in rational form. So we're just going to apply our properties. So it's going to be 4x to the 6/3, y to the 1/3, minus 3x squared, y to the 2/6. All right, because these are rational, now we want to reduce our fractions. So we're going to get 4x squared, y to the 1/3, minus 3x squared, y to the 1/3. Now these are our variable parts. They're exactly alike, so we can combine our coefficients. So 4 minus 3 is 1, so we're going to end up with x squared, y to the 1/3. And if you're asked to change it back into a radical, you can change it into a radical. X squared, the cube root of y. Just follow the directions. So depending on either form, depending on what the directions say. All right, let's look at one that's been on the SOL before. Look at the following question. So this was an old SOL question. All right, so when I look at this, I look at my numbers first, my 27, my 8, and my 64. And I think, how can I break these down? Well, 27, I can rewrite that as 3 to the third, x to the ninth, y to the fifth, to the 1/3. I'm going to change everything to rational. Plus 8 becomes 2 to the third, x to the fourth, y to the third, to the 1/3. And then minus, let's see, 64. 64 is 2 to the 6th, right? 2 to the 6th, x to the ninth, y to the fifth, all to the 1/3. Now I'm going to apply my properties. Okay, so what do I get? I get 3 to the 3/3, x to the 9/3, y to the 5/3, plus 2 to the 3/3, x to the 4/3, y to the 3/3. And then finally, minus 2 6/3, x to the 9/3, y to the 5/3. All right, now I'm going to start simplifying. So if I see improper fraction, I'm going to change them to mixed numbers. If I see, a whole number, then that's going to mean that the whole thing comes outside the radical. And then I'm going to combine my like radicals. Okay, so 3 to the third, that's 1, so that gives me 3. 9/3, that's x to the third. All right, my 5/3 here. I can rewrite that. 5/3 is what? 1 2/3. So that means what? A y comes out and a y squared stays in. Okay? All right, let's go to the next one. Plus, don't drop your addition. 3 over 3 is 1, so that just gives me 2. All right, so this is 1 1/3. So that means an x comes out and an x stays in. All right, and then 3/3 is 1, so that y comes out. All right, one more. All right, 6/3 is 2, 2 squared is 4, x 9/3 is 3. Well, we've done this one already, that's 1 2/3. So a y comes out and 2y stay in. All right, we're looking for the same variable parts. So that means this and this one are like terms. So those are I'm going to combine. 3 minus 4 is negative 1, x to the third, y, the cube root of y squared, and then I have my non-like term that just gets added on. And that's my final answer. So these are, like I said, you're combining all of these properties together and being able to handle the fractions. So it's all about practicing and getting good at simplifying these radicals. Okay, a couple more topics we're gonna look at real quick. Now the next thing, this type of question has been on an SOL in the past, where we have to square something with radicals in it. So we're just gonna FOIL it like we normally have. Okay. I'm not gonna simplify until the end, so I'm gonna FOIL first and then simplify. I think that works out better. Makes the problem a little bit easier, I believe. All right, so we're still going to use our same process. So when we FOIL this, all right, we're going to square the first term. So we're going to get 4, the square root of 9x to the 8th squared, minus, we're going to double it and multiply these two things together. I'm just using the squared pattern. And then we're going to square our last term. Square our last term. Okay? That's a 5 in there. All right, let's clean this up. All right, so 4 squared is 16. The square root squared is going to give me 9x to the 8th minus, all right, this is 8 times 3 is 24. These are not the same radical, so I have to keep that radical. I can only get rid of the radical if I have the same thing multiplied by itself. So I'll have to keep that. All right, and then finally, negative 3 squared is 9, and then you square a square root, you're going to get that term back again. All right, let's continue to simplify. All right, 16 times 9 is 144 x to the 8th. All right, this term. Here again, you can maybe are starting to be able to simplify this without changing it to a rational. If you need to change it to a rational, what's it going to be? Well, I got 24. The square root of 9 is 3. All right, and this is going to be x 8th y to the 5th to the 1/2. That I don't have to do anything with. All right, I'm just working on the middle. The middle is typically what you're going to have to simplify. All right, so what do we end up with? 144 x to the 8th minus 24 times 3 is 72. Half of 8 is x to the 4th. All right, 5 halves, which is 2.5. So that means y squared comes out and a y stays in, plus my 9y to the 5th. So I'm just simplifying from this step to here. I'm just simplifying those radicals. So that's my final answer. Like I said, this question has been on an SOL in the past, so that's why we make sure that we cover it. But it is good in the fact that you need to be able to simplify these radicals. Okay, one more thing, one more topic with this. Let's look at simplifying using conjugates. Now we did this with complex numbers back in Unit 1. We're doing the same thing, but now we have 1 minus the square root of 5, so like a radical. So here again, we are not allowed to have that square root in the denominator, so I want to multiply by the conjugate. So it's the same math that we did before. All right, so we're going to distribute the negative 4 and multiply our conjugates together. Now we know that anytime we multiply conjugates, the middle term is going to drop out. That's a good thing about conjugates. So we're going to go negative 4 minus 4 square root of 5 over, or on the bottom, I'm going to get 1, middle terms add out, minus the square root of 5 times the square root of 5 is just 5. So what do we get? Negative 4 minus 4 square root of 5 over negative 4. All right, let's clean this up and put it in standard form. So negative 4 over negative 4 plus negative 4 square root of 5 over negative 4. So my final answer is 1 plus the square root of 5. And it's just so coincident it happened to be the conjugate. It won't always be the conjugate. It's going to be your final answer. So please don't assume that pattern is true. Okay, so like I said, we're putting a lot of this stuff together. So please, if you have questions, we'll do some more in class. And practice is what you need on this. Practice makes perfect.